Today we got a D5K2 Caterpillar, and the first thing I noticed in the cab was laying the antenna and bracket. This is the auxiliary that goes back here. Not sure why they took it off. They look like they velcroed down the cable. Front one looks okay. So I'll just hook that back up real quick and then we'll test the system. Looks like they're missing an antenna for their modem. That's stretched a little tight. And here's the MCR3. This system apparently hasn't been used in about 8 months. So there's no telling what's wrong with it. Looks like a pretty good install though. Everything looks clean. Alright, we'll check it out. Let's install that antenna first. Alright, reinstalled the auxiliary antenna. We'll go inside and we'll take a peek, see what the system's reading. It might show that antenna is actually bad. We might have to take a look at it. Alright, let's see what the system tells us. They keep it nice and clean. That's what I'm talking about. Keeps it nice and clean in here. It's got the, it's actually needed the offset to center the screen on this bracket. This install looks like it was never used. Weird, they buy a system and don't even use it. I mean, this screen doesn't even have any wear to it at all. And they said they haven't used the system in over 8 months. Interesting. Well, 3DMC lights up, so that's good. And most likely we have different radio configuration. Nothing's coming in. We got antenna, we have satellites registering on the main. Let's see. And we have satellites on the auxiliary, so I'm not sure why they had the auxiliary off. This most likely needs an update. It does. That's 4.7. We need to put the 4.8 in there. Same thing with the main, 4.7, we need to put the 4.8 firmware. Let's look at the operating program. Needs to be updated as well. That's the old version, so we need to update the 3DMC operating program. So we have an X over radio, which probably means their base isn't on yet. Or they just haven't changed the radio settings. Whoops. That they haven't changed the radio settings since they used it. So we'll have to go figure out what their radio settings are and come back and enter that. So make sure it's... Alright, so first things first, let's do some updates on this machine. We're still not connecting to radio, so that might be an issue we need to look at. So, but anyway, let's get this system up and running. The first thing it's going to need and I got a lot of files in there. Look at all that. Wow. First thing they're going to need is this new 3DMC, which is 12.2.536, and we're going to run that and load that, and that's going to be the new operating program for 3DMC updated. And this is their FC6000 data collector. We're also going to need to upload the current project, which this one's called Holding Village 0428 042821. We're going to copy that one to D drive, internal memory. Come on. Huh. Notice this one has an issue with touchscreen. Man, it's freezing up too. I think they have too much on there. We'll power down and power it back up. Alright, so we loaded the new 3DMC operating software. Let's go into 3DMC and make sure it's there. Can actually cancel, we don't need that right now. Go into View, About, and there it is, 3DMC 12.2.536, and the date is 08/02/2021. So we got that in there. Now all we need to do is go in and update the firmware for the main antenna and the auxiliary antenna, and we can just go into True application mode, firmware loading, device, connect, and this is an MCR3, so it's going to be network, main. That's what we'll do first. Connect to it. Open up firmware loading. Receiver, yes. Next. Basically, let's go back, I'll show you. See, that's where it says firmware 4.7. We just need to find our hard disk right there, 4.8. Open it up. RAM image. Next. It's uploading the flash. Alright, that's telling us the firmware's been loaded successfully. We need to do auxiliary. It's just going to load the same file. And we've copied their current project. This project, the newest one, dated 04/28/21 3D, from their FC6002 flash drive. So we have that we can load in there as well. And we just need to double check their radio settings. And the auxiliary has loaded, so you can basically X out of all this now. Go back into 3DMC, double check that the firmware is updated. Receiver is not responding. The receiver is right there and it's not responding. Alright, I'll get to that one in a minute. Alright, let's just jump in here, jump into the GPS info 4.8 on the main, info 4.8 on the auxiliary. So this machine is completely updated now, and we just need to troubleshoot that no radio link issue, which could be something as simple as the radio setting, which if you hit configure, it'll tell you what channel. So they're squawking on channel 464.6 megahertz at 25. It is PDL Rover, GMSK. We just need to make sure this is squawking at the same. Alright, so firmware is uploaded, 3DMC is uploaded. Now, let's work on this no radio issue, which is probably just simply the project. So if we load the right project in here with the right base point and control points, we should be good to go. Let's see if that happens. Still waiting for radio link. Except that there's something wrong with that right there. You see the distance to base? That is not correct. That tells us we have definitely a radio issue. Well, let's get some radio information. If I can get this 6000 to connect to this antenna, for some reason it will not. It will not. Strange. Okay, so after some shutting down and repowering up, their rover antenna finally decided to connect, and we are definitely on the wrong channel for this machine, which I figured because they haven't used it in 8 months. Normally people change their channels. So we're actually on 464.550 at 25. That's at 12. Yeah, we might have to load the channel in here. That's at 12. We need 550. Oh, there it is. Alright. Alright. And we're actually on 4FSK. Enabled, link rate. Shouldn't matter. We'll set that, and we should have radio connection now. Come on, cook it, cook it, cook it. And okay, waiting to initialize. X is off the radio, and radio is looking. It's waiting to initialize. Waiting for radio link again. Really? Huh. Come on. Let's do this. Let's just go in here, restart connection. We'll give it a fresh connection. There we go. Alright, that's it. Alright, so now we're good on GPS, we're good on radio, we're updated on firmware for the GPS antennas, we're updated on the 3DMC program. Now what we need to do is go in and actually physically check to make sure that our calibration, our measurements for this machine are good. And the last time it was done was 2019, so I'm sure there's a little bit of wear here and there, so we'll retake measurements and we'll actually recalibrate this machine, and we'll check them against actually used a direct instrument. I'm going to use tape measure, and we'll check all these numbers, measurements against what I take, and we'll get this machine tied right into the project nice and tight, and we'll get them back to work. So with that, let me take and move this machine someplace up on higher, drier ground. Alright, first things first with the calibration on a dozer. This is a Max system, and with the Max system we got a blade sensor and a body sensor. No third C-frame sensor. We just inspect as we go, make sure nothing's damaged. First thing we do is we set the blade square to the machine. It should be square to the machine, so even on that side, even on that side. And once the blade is squared to the machine, you're going to need to take all these measurements right here. Alright, you're going to have to clean under the tracks a little bit just to see that crosshair on the body. And you need to be able to get to that joint right there and just make this smooth for your... Okay, so we pulled all the new measurements for this dozer, which we're not sure if anything has changed. We're going to have to calibrate and measure and just check against the model. If you want to see a new calibration, a full calibration, look at my newer, older videos, the first videos that come up. I think there's a John Deere on there. So anyway, machine setup. Going to modify this, so edit. I'm going to change that date. I believe it is 9-20. What is the date? 24? It's the 23rd. 23-21. It's a Wednesday. Bulldozer, GNSS, cab dual roof, yes. Feet, yes. MCR3, yes. Tape measure, yes. Disabled, yes. Alright, so let's check these out. So number one, where's that sensor in relation to the right corner of the blade going up? And I got 2.845. I got 2.74. I'm going to go with mine. Two, how far inside? I got 8.30. I got 8.43. Hang on, before I do this, let me just cancel that. Let me save that old file. It's always wise. Save that old file and then save the new file. Just in case your numbers are messed up. Which I don't suspect my numbers to be messed up. Alright, so we got that saved. Alright, I got that file saved on my flash drive, and I've also went through and I've taken photos of each page so that I have quick access to the numbers in case I need to adjust later on. So yeah, modify, let's edit. We're going to take that date out. We're going to enter today's date. Let's go straight into adding the numbers. I got 2.845. That one I got 8.30. That one I got 1.09. You see that's 0.3 off. How they got 0.3 difference than me, I don't know. Half of the blade, 5.27 is what I got. Center of rotation going up, I got 0.97. Body sensor, number one, how high is it off the ground? I got 2.23. Inside, number two, I got 3.85. They got 3.84. Distance from blade, 6.36. Wait a minute. 9.66 is what I got. Pivot point, number one, how far off the ground I'm going to leave it. because I couldn't get to it. It was too muddy. Number 2, this is the big one. This is, if that's too far, the blade is going to think it's out further. If it's too short, it's going to think it's in closer. So you can either be chopping too much or taking too little. You can also see the whip-de-doos that happen. It's usually because of this number 2 measurement. And I got 6.36. And core behind, I got 1.52, and that's what they got. So, alright, so number 1, we got 7.57. Number 2, I got 4.90. And these were shot with an instrument. I don't like the instrument because if that bubble's off just a little bit and it's not straight up and down, it's gonna get a different value this way, different value that way. You see how much my thumb moves? Your bubble has to be perfect, and it's just impossible a lot of times to get that way. So they got this at 6.56, and it's actually 7.18. 7.18, make them the same on both sides. 2.79, 2.79. Track width, I got 7.93. They got 7.88. I don't like instrument. Antenna offsets. How far back is that antenna? I got, let's see if I can find it on here. Where did I put it? Oh, there it is. 7.75. They say it's 13.12 feet. And I got 7.75. Alright. Let me show you this. They say it's 13 feet back. Let's set that in, that tape measure down. We'll draw this out on the side of this dozer, and we'll go 13 feet. Look at where that ends up. That's where they say that antenna is, at 13 feet, when the antenna is right there at 7 something. Big problem. I don't know if that machine ever cut right with that. That's a huge issue right there. Holy cow. Width of the blade, 10.54. That was way off. I don't know what the deal was with that one. Alright, so, and then here, number 3 is the big one. I got 5.17 distance between the two antennas, right there. They got 3.42. Wow. These are 0. They're not offset. They're perfectly in line and level with each other. That was way off. And that's it. That's it. That's it. Save it. Now we'll go calibrate. Alright, so the first part of calibration, and I'll show you how I got to it. Whoops, let's exit out of there. Control, MC2 plus calibration. You're calibrating the sensors. MC2 plus sensors just work right down the list by hitting next. So we're going to do MC2 plus sensors, calibrate. This one tells you to measure the body slope and then match the body slope with the blade slope. So you're just going to bring the blade to where you need it to match. So our body is sitting negative 2.5. You can see it slumped down this way more. And our blade is sitting negative 2.5. Just get down, just check, make sure it looks lined up, and it does. So That looks good. So negative 2.5, body and blade. And what are we reading? Negative 1.2. Boy, did this need a calibration. And set, and just let that cook. Making sure it holds the value you entered. Once it's done cooking, next. Now this, I've already taken these measurements. That's this one here. Number 1 is going to be from corner edge to bolt, which is 1.45. Number 2, bolt to bolt, 7.60. Next, now the blade geometry, which we've already done as well, right here. You're going up to the center of a bolt from the bottom cutting edge, and then you're going to do like a squared. So number 1, we got 0.27. Number 2, 0.22. Alright, so the next one, we have to basically do the main fall, measure the tracks on each side, and find the happy median. So we're going to need our instrument. I've already cleaned these tracks off. Try to bring it to the back as far as you can without actually going up the little slope that's there. Take the reading. This is going to be a negative because it's dropping down in the front. Negative 6.8 on the right. Get you a clean surface. Negative 6.87 on the left. So 6.8 right plus 6.7 left equals 13.5 divided by 2. 6.75. That should be reading negative 6.75, and it is not. So we're going to change that. Let that cook. And good. Then all you need to do is go to the next. This next one, you're just raising the blade all the way up, high as it can go, and you're just putting the blade at 0.0. And I use magnets. That's recommended by Topcon because the cutting edge is usually wonky on one side, depends on how the operator digs. Once you're at 0.0, you basically have to change that slope, because right now the slope thinks it's at negative 1.2. It's not. So you go over here, you change the offset. We're going to put in 1.0 and see where it goes. Should take us closer to 0. Might have to go 1.1. We'll do 1.2 because it was 1.2 offset. So you get to 0.0. That's it. You've just now straightened your blade out. Your sensor knows that's 0. And you hit finish. And then you move on to the next one. Blade alignment. Alright, blade alignment, basically your blade is already at 0, it's square, so just bring it down until it just barely touches. It's going to touch on one side more than the other depending on your territory you're in. Hit next. This is where you're going to have to crank up the RPMs. Full blast. Cock it. Hit next. Do it the other way. Cock it left. Hit finish. That basically gives you your limits of that sensor. And then we can go to next. This is the pitch compensation. Park dozer on a rigid surface, which it is. Raise the blade in the air to measure the cross slope. You're just going to raise this up, about maybe an inch or so. Center the blade. Go out and take a measurement. Just be consistent where you measure. I usually measure right in the center right here, and it looks like we are, this tape measure is so weak. 0.11. That's with the blade straight. You're going to come up here, you're going to enter your value, 0.11. Then they want you to rotate it all the way to the right. Take the same measurement in the same spot. You're going to do that when you rotate it to the left as well. And the last calibration you're going to do is going to be the body heading. So basically you need to be able to get that back end raised up so you can perform this. Now we got a nice hill over there. We also got a nice little swampy spot right there. We got a little spot over there. So I'm just going to drive around until I find a spot where I can get this back end jacked up just like that. We're going to zero the body and we're going to set it at 0. It should be already at 0, but it might be off. We'll just change the heading a little bit and correct the slope. Man, it's like a racetrack around here. Looks like a perfect spot right there. Yeah, that looks like it's gonna work. Woo, man, it's slippery. I'm sliding in a dozer. So it's at 0.0 now. So I just need to get out and check and see if we are close without this dozer sliding around on me. Alright, so the body's at 0 and it's reading 0. So, and this goes back to the operator can feel it in his seat, right? Which you can pretty much tell, but so all we need to do is basically hit finish because that is good. Alright, so now the calibration is done, new measurements are in it. We need to check this against the model to make sure our blade corners are right where the model says they're supposed to be. So I gotta get this thing spun around in this mud here and get back up this hill. Alright, so using their rover on the corner of the blade, and you want the center of that running right along that cutting edge as close to that corner as possible. Right now we got probably about 9/100ths to a 10th right there, so that's going to put us, whether it's east or north, that's going to make us a 10th off, basically. So keep that in mind. I think they shut this down. Well, let me start this. Alright, so there we go. We started, we got our rover set up. And basically, we just need to be able to set this point. You can see we're in some kind of parking lot, maybe. Oh no, these are housing. Looks like housing pads. So we're going to take a shot. And that's what we get on the right corner. And where's my phone? I can't take a picture of it. Gotta grab my phone, left it in the cab. Oh, so much for a nice clean cab. This operator's gonna hate me. Anyways, alright, so we got the shot of that point we just shot. Now let's go in here, tools, position check, right side measure. Measure in that right corner based on all the measurements we took in the calibration. Check the northeast elevation and see if they match. It's off 2/10 for the north, so that 1/10 right there could be the difference. That's still within specs. 04694, that's within specs. 35447, 35444, so we're 300s off. I can deal with that. 300s is no big deal to me, so that's what we get. Very first shot I didn't have to adjust anything. Now we do the same thing to the left side. Go in, do a position check on the left side, and we'll go over and shoot the left side and see what we get. Alright, this is our left side. Looks good. The north is off just a little bit, but that little attachment they have, I think, is causing that. East is good. Elevation is 400s. So how much is 300s and 400s? Well, I brought a little rock up here to show you. There's a little rock right there. Let me put my finger on it so you can see the size of it. That's a rock, okay? So this is tenths and hundredths. The width of this rock is about 300s, okay? So 1, 2, 3, 4, 400s is smaller than the width of my finger, smaller than the width of my pinky. 400s is smaller than the width of my pinky. So basically what that's saying is that's how much clearance from the blade to the model we have. Discrepancy, I would say, more so than clearance. A pebble. So that's not bad at all. It's good calibration. Now we just need to turn this thing around 180 and check it on the other side, make sure it matches, nothing funky's going on, and we're good. Be sure to save your new machine file. It's got the new date on it. It's got all the new measurements in it. It's got the new calibration in it. And it's saved. And there's one last thing I want to check before I do a 180, but I need to move this rover out of the way. Alright, so we're going to check the valve offsets next, and it has to be in autos, so make sure the autos comes up. Control, valve offsets. Basically what we're going to do is just let it go, hit set, and that blade should raise. Don't forget to turn up the RPMs. That blade's not going up. Increase the value until it starts to go up. Still not going up. Put it back where I found it. Oh, that's why. Hydraulic lock is on. There we go. That's way too fast, way too fast, way too fast. Still a little bit too fast. That's about good. Now come down with it. Down looks good. Go back up. Bump that up just a little bit. That looks good. Come down with it. That looks good. Now we'll do slope. Too fast. Slope the other way. Too fast. Way too fast. Right about That looks good right there. That looks good. That looks good. Go up with it. That looks good. Come down with it. That looks good. All right, valves. Valve settings were off. Now, go in here and check their elevation gain raise and elevation gain lower. They got it at 50 and 36. That's operator preference. But because they haven't used this in a while, we're going to change these back down. Something a little more manageable for them. And also do the slope, which is right here. They got slope at 40. We're going to set it 30. And the operator can come in there and change those depending on his operating conditions. If he's going really fast, he might want that blade to adjust faster. If he's going really slow, maybe he wants it to adjust faster or slower. So, and that's slope gain. That's how much it's going to correct itself, how slow it's going to go. The higher the number, the faster it's going to correct that slope, and so on. Whoops. I hit cancel instead of... Okay, that's it. Now let's just do a 180. Alright, so I did a 180, reset the rover, which it's not down all the way. I just kind of hurried up and set it there just to get a quick reference. And sure enough, it's 600ths off, which makes sense. We're actually only 3 to 400ths off. It's just the difference of the way that's sitting down there. So, I mean, that's good. That's good for me. And, oh yeah, by the way, I saved the machine file before I did the valve offsets. Don't forget that if you change anything after you've saved, just go back in and resave. And it'll resave. So we don't need this one anymore. We saved that on here. We don't need it. We can delete that one and we can use the brand new one. Hit OK. That's the one they're going to be using. This machine is ready to go to work.